Good morning, everybody. I would like to welcome Rajnish, and I would like to welcome you all as well to today's mechanics lectures. And today, Rajnish would be talking to us about a very interesting topic. I think it's a hot topic today on machine learning and artificial intelligence. But he would be going one step ahead because most of us would have looked at problems like NLP and image processing with these things. But Rajnish would be telling us about how it is used in mechanical and aerospace industry and particularly with his experience in Rolls-Royce and how they're applying in there. Just to introduce Dr. Rajnish is an aerospace scientist, visual mathematics evangelist, and a staff data scientist. He has 12 years of experience in applied research experience in aerospace and mechanical engineering sciences, machine learning, R&D. He did his doctorate and a master's in aerospace engineering from the Indian Institute of Science, followed by a postdoctorate in applied mathematics and aerospace engineering in IISc itself. He has worked for several years in the Rolls-Royce in the jet engine division and also at various technology and strategy roles in Rolls-Royce and directly worked under the CTO in the innovation hub at R2 Data Labs. I mean, he has a lot of experience in applying data sciences into the mechanical engineering and aerospace problems. And I'm quite excited to see what he has to tell us. And I think all the audience are also excited considering we already, okay, it was 50 when I started introducing Rajnish and now it's 68. So I think everybody is interested in the talk today and thank you everybody for joining in. It's very nice to have an enthusiastic crowd. And please feel free to ask Rajnish any questions. You can type in the chat box and let us know any questions. And maybe we will try to see how to organize the questions as we go through it. Right. Thank you, Rajnish, for taking your time and joining today on a Saturday afternoon and spending this time with us. I'm sure everybody is excited and I won't keep them waiting. So the stage is yours.
Thanks a lot, Ajay. Thank you. First of all, I would like to welcome everybody aboard on this prestigious mechanics series, lecture series, and also would like to express my gratitude to Dr. Ajay and Professor Dinesh and a couple of other NM cadets. Most of you might be all aware of what is NMCAD in ISC. And so before any ado, so let me start with the today's talk. Welcome you all. Good morning, good evening, good afternoon across the globe. And I'm Dr. Rajnish Mallick, and I'm going to talk today on machine intelligence in mechanical and aerospace sciences today and beyond. So before we get into the whole interesting topic of machine intelligence, let me quickly brief about why I wrote specifically machine intelligence, not artificial intelligence, generally, which is a term which is quite famous and quite prevalent. Most of us are working in the domain of machine intelligence, which from the inception of very much when we go into the area of artificial intelligence in 1950s, I'll look into the timeline also along with you. There, the whole concept started with that we would like to generalize an analogy of a human intelligence. So that's why what that actual term artificial intelligence connotates is artificial general intelligence, AGI. What we all or most of us work is artificial narrow intelligence, or precisely as in line with the academic research literature is machine intelligence. So I'm going to touch upon the key case studies and applications around that in aerospace and mechanical sciences, and also going to give you a key aspects around that, what are my recommendations around it. And on the bottom left, you see one particular diagram, which I have created, which I call as a knowledge triangle. We'll discuss about that also. That is pertinent for the people who are interested in the management level, senior execs, and would like to be in that role. All right, let's begin with the agenda. So the first I'm going to talk about the motivation, that why we should invest our time and energy in learning machine intelligence, and specifically from mechanics and mechanical and aerospace sciences perspective. And then in the second part, I'm going to talk about the applications, as I said, some case studies around machine intelligence in mechanical and aerospace industry. Specifically, I'll touch upon aerospace and mechanical engineering domains, Otherwise, civil engineering and other couple of domains also comes under the gamut of mechanical sciences. So a couple of case studies I'm going to talk about is on the AI in design, machine vision, augmented reality, and mixed reality. And something which is very close to me from the visual mathematics perspective is the data visualization, and what I call as data sinks. In the third part of the presentation, I'm going to give future research and technology opportunities. This will be very useful for the audience here because we are having people from the UG research background, professors, and different visionaries. So this is the brief of the agenda. So stay tuned, and I look forward for your questions in the end as well. All right. In the motivation part, as I said, I always try to address, and also when I do introspection, I ask that why I should do this and why I'm doing this. The same question I'm asking here: why should I learn machine intelligence? And here, on the left side, you see the hype curve. This cartoon is known as hype curve from the Gartner, which is a management consulting organization. This is the report which was published by Gartner in the late 2019. And here you can see on this hype curve that the AI technologies have already started coming in. The AI, what I mean here is artificial intelligence. And to be specific, I'm focusing more on the machine intelligence part, which I already mentioned. But as we go towards the timeline towards the right, from left to the right, then we see that these technologies on the hype curve is something which we need to focus on, especially the technologies which are in the cyan color over here, which is going to be 5 to 10 years down the line from the emerging technologies perspective, and also the blue dots, which are the today, which is going to come very soon. So here, if you see quickly, so let me give you one quick example, which I'm going to discuss in detail also. There is something known as explainable AI or XAI. There's a wonderful report by DARPA, and also now we have our own national AI report, which was published in 2018 by Niti Aayog, the Planning Commission earlier of Government of India. So here we need to focus on something, not only the AI part, we need to focus on why is it happening like that. So it's not a black box. There's a brief mathematics around it and strong foundations of statistics and multivariable calculus and linear algebra. So, right, so we'll discuss on that briefly. So what I want to tell you here is, in the end, when we're going to share this presentation, or maybe you can also talk with me. So we need to focus on appropriate technologies when we are looking at the different time scales. So if you're looking into your organization or in your lab, so you can look into that particular technologies. If you can see now 5G is already into the research mode and it is taking across. And I heard recently Nokia has also started a tie-up with the Indian Institute of Science on a 5G Center of Excellence. So coming to the machine intelligence part, if you see on the right side of this particular picture, this is again from management consulting organization from McKinsey. And this is a recent study where, how to read this particular diagram is if you go towards the right and the top of this particular quadrant. If you see that, make this particular figure in 4 quadrants, then the top right quadrant is something we need to focus on. These are the leading sectors which are monetizing and making inventions and innovations from the AI, right? And there is an opposite 180-degree falling behind quadrant over here. So now if you see it over here, so the automotive and assembly sector, energy resources sector is something which is really leading sectors. That's why if you see from the hype curve, from the AI demand trajectory and who are the leading sectors, the mechanical and aerospace sectors are really at the forefront. And this is the right time if you really want to get forward and want to invest your time and energy into learning and hone your skills further. Now, a quick brief definition that what is machine learning. It is a term coined by Arthur Samuel in 1959, which meant the ability to learn without being explicitly programmed. Yeah. So if you see this particular timeline, as I was mentioning earlier, so from early 1940s to 1956, the AI first conference, or the confluence which happened earlier in 1950s, that all focused, the whole class of scientists started focusing on the artificial general intelligence, on artificial intelligence. And later on, there has been the three waves of AI, right? So right now, what we are seeing in today's generation, especially the millennials, what we are experiencing is the third wave of AI. This is not the first time the AI boom has came up into the forefront. So the first came over here, the second came in 1980s, and what we are experiencing is because of the revolution in the nanotechnology, the miniaturization, storage, and computing capabilities, and also on the advent because of the inception of certain wonderful algorithms, also by Professor Jeffrey Hinton in 2012, if I recall correctly. He's also known as the father of AI. And since then, the lot of focus started coming globally on making the image-related neural networks, and a lot of papers, and especially the ImageNet, they all started coming along in the Stanford, and then the whole world started using it again in the third wave. Remember, this is the third wave, this is not the first time, right? So we have to be cautious that what is possible and what is really a hype, yeah? All right, so here in the bottom right corner, you see a small snippet where I try to distinguish, which I earlier called, what is artificial narrow intelligence and what is artificial general intelligence. And please appreciate, and I would like to draw your attention towards, that what most of us are working towards is on the artificial narrow intelligence, right? Or let's be precise, let's call it machine intelligence in line with the literature, yeah? Artificial general intelligence is towards when somebody really try to make human equivalent robots which have the same cognitive capability, which is not most of us are working towards, right? We are the mechanical and mechanics community from the aerospace domain or many other domains. So we want to focus on the machine intelligence part, yeah? All right. So what's the rationale? If you see, there's a term known as AI continuum, and so initially we all started focusing on assisted intelligence, right? Like small bots, which Motorola and Honda and a couple of other companies, especially from Japan, they were at the forefront. And then the second part, we went into the augmented intelligence. Whatever we know, we can augment that knowledge. How we can augment that intelligence, and for our betterment, for better productivity, for better efficiency, precision, right? The third part of the AI continuum is the autonomous intelligence. That is towards really going towards that self-driving cars and something which is highly cognitive related and highly cognitive driven equivalence of human intelligence. But as I said, I mean, there are a huge amount of and lots of terms which are coming along, which most of us are already aware of. But I would like to make a caution statement over here. Sometimes we really fall into the trap that, there's a huge amount of information we need to learn or relearn or unlearn. That's sometimes true, but please appreciate whatever we are as, PhDs or masters or undergrads, or so the information which we get as part of our curriculum is enough that we all can quickly either transform, or we already are actually machine intelligence in the domain, yeah? So let's not try to chase unicorns, that, the person who knows everything around the world, right? So because the good part is that unicorn don't exist, yeah? So I'll talk about this particular knowledge triangle in detail in the third part of the presentation. But briefly, what I would like to emphasize over here in this knowledge triangle is that the key thing which we all are good at, when I say we all, so the domain, when we invest our time and energy in mastering aerospace engineering, mechanical engineering, civil engineering, or alike, that's the domain specialism, right? And we also master the applied mathematics as part of our curriculum. Now, if we complement that with a little bit of these other scientific or technical computing technologies along with software engineering, then we are really a decision influencer and we can enter into the area. Otherwise, we are already there. We'll talk about this in detail, and this is also pertinent for the people who are already in the CXO level or who want to move to the CXO level, right? So let me quickly get into the second part of the presentation, that is the interlace between machine intelligence, mechanical, and aerospace sciences. In this second part, I'm going to talk about a couple of demonstrations and case studies from research and technology perspective, not only R&D, but R&T. As most of us, we will be aware of that there is something known as TRL levels, technology readiness levels. So R&D generally happens in the universities where the TRL level is around till 3 or 4, and there is an overlap from 4 onwards. We go into the industrial R&T, that is our research and technology. So I'll be focusing more on the research and technology part. I'll be going to talk about the applications in design, AI in design, machine vision, predictive analytics, and also the new vision to your vision using virtual, augmented, and mixed reality, VR, AR, and MR. And also a little bit on the factfulness by Professor Hans Rosling on the field of data visualization, as it is not just plotting. All right, let's get into the AI in design. So I'll be switching to the video.
Learning three-dimensional flow for interactive aerodynamic design. In this paper, we introduced a novel approach based on machine learning to predict the aerodynamic.
I think we lost the video, audio.
Dynamics of free-form 3D objects in real time. This opens a new avenue for interactive design of aerodynamic learning.
Rajnish, we can't hear you. No, not yet.
Learning three-dimensional flow for interactive aerodynamic design. In this paper, we introduced a novel approach based on machine learning to predict the aerodynamics of free-form 3D objects in real time. This opens a new avenue for interactive design of aerodynamically efficient objects. Traditional CFD solves the Navier-Stokes equation on a detailed mesh and might require hours of computation on a high-performance computer. Given a previously unseen new 3D shape as input, our tool predicts the velocity field around the shape, the pressure field on the shape, and its drag coefficient. Our tool also visualizes the accuracy of the prediction. Here, the width of the needle in the drag coefficient indicator shows the predicted standard deviation of the error, corresponding to the 68% chance the actual value falls in this range. Our system is not tied to a specific geometric representation of the shape. We can handle typical shape representations such as triangle soup or parametric surfaces. Our workflow starts with the training phase. First, we collect hundreds of shapes and execute CFD computations for each shape. Each input shape is parameterized using our polycube mapping approach. The deformation of a polycube template to fit the object's shape defines and encodes the input shape as a fixed dimensional vector. Hence, the polycube deformation vector is perfectly suited as input for machine learning. We also use the polycube to construct a hexahedral grid around the object. Using a Gaussian process, we infer the velocity or pressure values at the nodes of the hex grid from the training data. From different base representations of the polycube, we can parameterize a wide variety of input shapes. We validated our approach using cross-validation. This is the error distribution from tenfold cross-validation. We achieved an accuracy of around 3.4% in drag coefficient prediction, which is comparable to the accuracy of regular wind tunnel experiments. Here are some of the comparisons with our prediction against the ground truth. Using our tool, we designed and fabricated an aerodynamically efficient 3D car top sign. Thank you for your attention.
All right. I'm audible again?
Yeah, you're audible, yeah.
All right. Thank you, Ajay. So here, this is the work on the application of machine learning in AI for design in CFD domain by Autodesk. And there's an interesting, the full-length paper is also available over here. So it's available in the ACM transactions. So here you can see that, using the regression and the CLCD parameters along with the pressure and the velocity contours and the profiles. So there's quite a lot of applications which we can really use to fast and make the design fast and cut down the design cycles, especially in the particular domain where we know the particular profiles, right? So it is you can think about it that it's a very smart way of optimization, yeah. And the video already demonstrated. So they use the Gaussian processes, GP regression, for entering the CFD simulation data, right? The second key example is also from the wonderful work by Noor, which was published in a mechanical engineering magazine. So over here, you can see that, especially Airbus now as part of the industrial sector is really taking a leap forward along with the other, what I call as a 2x2 metrics, Rolls-Royce, GE in the engine manufacturers, in the extra wide body engines, what I mean, and then the airframers such as Boeing and Airbus. But Airbus is taking a leap forward from the airframes perspective to really kick the domain for AI in machine design really forward. And if you can see that the design of the aircraft, especially when I say Airbus, so they have a special kind of division, what they call it as a cube. They work on the research, technology, and innovation and the emerging technologies, and they use the AI in design. And recently they have used computer vision and machine vision and landed the full-scale aeroplane without any human assistance. So that level of precision, when we start getting in our design, in our analysis, and also in our day-to-day complex operations in aerospace domain to name. So that really builds the confidence that there is something which we can complement, not replace, but complement our domain knowledge, right? So that we can enhance our productivity. So now I'll quickly go into the second part of this applications in the machine vision. So machine vision is that when we assist the machines and enable them even further using the assistive vision technology so that they can do certain operations which with naked eye sometimes it is complex, or we really need very high professional and highly experienced experts in the QA, quality assurance departments, which are really sometimes expensive, and we still are being human can have some kind of errors. So how we can reduce them? And as I'm emphasizing, this is all about assisting the humans, complementing our knowledge, right? Not replacing. All right. So what is machine vision? So as AIA lists, that is Automated Imaging Association, machine vision encompasses all industrial and non-industrial applications, which a combination of hardware and software provide operational guidance, right? It's an assistance, the guidance to devices in the execution of their functions based on the capture of the phenomena which is happening with the software and the hardware, this camera, and processing those images, right? Let's look one quick example, and I'm also giving you the open source data set, which we can use in the MRO facility, that is maintenance, repair, and overhaul facility, and from the CXO or the business-oriented people, and also to make a financial-related good case study or publishing the work also. Please appreciate the MRO is the part of the whole cycle in the industry where maximum, in fact, more than 50% of the revenue for any general company comes. That's a key, interesting, useful services sector for any industries, name it in aerospace, mechanical sciences, or be it any industry. So there is a very interesting open source data set known as GD-X-ray. It's an X-ray images data set, and the application of that is in the non-destructive entity testing. So how we can use that in MRO? So here you can see these are the 6 classes, right? So in machine learning, these different particular defects is categorized as different classes. So there are 6 classes. We can use classification algorithm, right? So this is the hint, the people who are accustomed to machine learning. So like tracing, inclusion, patches, pitted surfaces, rolled in, scratches. And if you see in the gas turbines or jet engines, what we call as gas turbines, so there in the high pressure turbine zone, what happens is these type of defects can really lead to nucleation of cracks, and which can lead to sometimes contained damage or sometimes catastrophic damage, which definitely nobody wants. And also please appreciate kind of a damage, especially catastrophic or contained damage also, or one particular, let's say an engine, a jet engine, cost millions of dollars of loss, and definitely reputation also gets losses. So we need to understand how we can use the machine vision, and early on using non-destructive testing techniques, which are sometimes not very much visible with the naked eye, how we can utilize the technology such as machine vision and categorize our classes and also complement the QA department, and then tell us that this is particularly is going to happen with some kind of predictability and predictive analytics, which I'm also going to talk about soon. Yeah, so I'm also listing the paper. Some of us are interested in that. There will be applications of machine visions, such as guidance in identification of defects, right? In gauging, so if we really want to measure it, in inspection, in the QA department, that is very much critical. And also it reduces the downtime in the operation of the aircraft. So the third part, I'm going to give you a quick indicator and would like to inspire you what I earlier mentioned in the last slide on the predictive analytics. So here you can see this particular 2 plots shows the predictive analytics analysis, which I have done myself. So here, what I'm trying to calculate is a remaining useful life, which is very critical component, and it's really useful when we really want to get into the publication and the research mode, and would like to apprise and disseminate our knowledge. And also from the industry perspective, when we really want to cut short our losses, because let's take an example of a jet engine, right? This is a jet engine health monitoring problem. So now, if let's say on the x-axis you see that this is the timeline. If a jet engine really goes into the workshop and gets stripped apart, every single component and part of that is stripped. That is the terminology we use in MRO. So that is only happens 2 or 3 times in the whole cycle of a full jet engine. That is approximately 20 to 30 years. Right? So that's the time scale. If I can save one particular shop visit before it really completes its full lifespan, that's a huge amount of saving to the company. Right? So from that perspective, we also really want to do the diagnostics, which is anomaly detections, and also the prognosis, that is on the prediction, what it should going to behave, right? So here the blue dot shows the raw actual data, right? I have normalized and also masked the numbers over here, that what that actually means. But people who are in the jet engine community or from the aerospace domain, they should know. And you know, the pressure at the different stations, such as before the LPT, before the HPT, that the pressure station 30, and turbine gas temperature, TGT, and a couple of other parameters which are publicly available in the research domain. They are the critical ones. So one of them I'm plotting over here. So that's the blue dots. And it is only available to me, let's say, till November of 2011. Yeah. So now using the algorithms, here I have extended it using the non-linear recursive least square methods, which is inspired from Kalman filters and extended Kalman filters. And here you can see in the second subplot that the blue dots, when I try to overlay the predicted curves, that is the dotted red line, started really mapping it. And I'm able to predict over here that when the engine is going to go to the workshop. So that really saves money, repetition, downtime for the operations of the engine. Yep. All right. Now, let me get into the second part of the second phase of the presentation, that is towards mixed reality. And also, most of us have heard about the Industry 4.0, and I'm going to introduce you to the Industry 5.0, that is HMI, human machine interactions, and also when we are going to immerse in that using immersive technologies such as MR. So before getting into the small video to let you appreciate that, let me share one case study. This is all publicly available data. So this is the Boeing case study. So here you can see that using the AR technology, which Boeing has used, that is the augmented reality. So their efficiency levels really goes 20% up than what they had, which they called earlier at the time as 100% before AR. And then the productivity went 40% up, and time consumption goes really almost 15% positive and 25% positive. So, and if you see other case studies from the equivalent industries in the aerospace domain, such as GE, that is General Electric. So here, so we can see that the improvements in efficiency is around 8 to 12%, and the reduction in errors are around 85%, which is massive, massive amount, right? And this is the statement from the Chief Strategy Officer of GE Upskill, right, which testifies that why and how it is critical to the industries such as jet engine manufacturers, right? So the statistics of the increased efficiency and reduction in error in the MROs, right? So this is the maintenance, repair, and overhaul systems where the revenue comes, maximum revenue comes. So we need to focus on that. And these type of assistive technologies can really boost that. And these are the other particular beneficiaries, such as the UTC Aerospace. NASA is also using mixed reality in training their astronauts. Airbus has also developed its mixed reality trainer for A350. XWB is the Rolls-Royce engine, extra wide body engine. And this is the complete summary of that, where right now in the public domain, whatever is available, these aerospace industries are in the mixed reality, augmented reality, and the virtual reality. And most of them are already moving towards from VR to AR to MR. And Rolls-Royce has also entered into the AR. And we can see easily that MR Airbus is there. As I said, I mean, you can look into the AQ later after the presentation as well. So, okay, a quick brief timeline again from the industrial revolutions. We know that when we started using the steam power technology, then that was the inception of the Industrial Revolution 1.0. Then we moved to the mass production assembly lining and started using the mechanization using electricity. That was the inception of Industrial Revolution 2.0. Then we started more, inculcating the robotics into our systems, into our mechanization and the production lines. That started and commenced the Industrial Revolution, 3.0. Then there was the cyber physical systems and Internet of Things, which already is very much part of the ERP processes in the industries and production lines. That is the Industry 4.0. What I'm going to show you right now in a small video is Industry 5.0, where you are going to experience human-machine interactions and the immersive technology. So I'm going to disconnect my audio for a while, let you experience that.
The video. Is there a video there? Sorry about that. Is there a video? We can't see the video. We can only see the Industrial Revolution slide. Yeah, I think now it's visible.
Service center or senior specialist, he can use the remote assistance button. A video call is activated between the mechanic and the service employee on duty.
Show full size. Full size. I can continue to train at the action escape.
Fuel nozzles. There are a number of nozzles designed to inject the fuel into the combustion chamber.
Safety is a hugely important part of training with machinery. Hololens not only allows trainees to negotiate that machinery in complete safety, it can also present hazard areas in new, unique ways.
Please be aware of the areas marked as hazardous. In a real-life scenario,
system reacts very well.
The fuel passes through each part of the system, being filtered, heated, and pressurized, ensuring optimum engine performance.
In this short amount of time, Aracha was able to switch from her daily work to dive into an important training where she learned about a newly upgraded airplane engine. Hololens gave her the flexibility to learn in any location, at any scale, and at her own pace. Any company that needs to train and develop their employees, and any partner who helps companies with professional training has a big opportunity. You will
All right. Audible?
Yeah, you're
All
audible.
right, okay. Thank you. So that was a quick demonstration of that. What is the assistive immersive technology, and which is really going towards industry 5.0 from industry 4.0, right? So now quickly, in the interest of time, as well as to show you something which is very close to my heart, and also something, a new curriculum where I'm drafting my book on visual mathematics. So I'm going to tell and inspire the audience over here that what I call as data visualization is not only about plotting. And I'm going to show you again one small demonstrative video that is, there's one wonderful book by Professor Hans Rosling. So this person over here is Professor Hans Rosling. He's no more. He was a Swedish researcher, scientist on the global health economy. Let's experience that, and please let me know your thoughts later on LinkedIn or later on. Okay.
Visualization is right at the heart of my own work too. I teach global health. And I know having the data is not enough. I have to show it in ways people both enjoy and understand. Now, I'm going to try something I've never done before. Animating the data in real space, with a bit of technical assistance from the crew. So, here we go.
So I've just made a small pause to make it more interactive with the audience. So if there are any questions, please let me know. Otherwise, definitely we can have a small conversation later on after the talk. But this particular presentation part is on that why and how one should really present your results. I'm not saying that we need to really get into the tech which Professor Hans Rosling used, but there is a tool which is known as Gapminder, which Professor has developed, and it was earlier, later on acquired by Google. And let me tell you that that happened only during one of his TED Talk, which happened in 2007, and then the whole software was taken up by Google. So that's the impact that one should make by really emphasizing and collating and presenting your results. So it's not only about just throwing some plots, it's how you should present. And there are different techniques. We can really get into the visual part of demonstration and presentation. So experience that and learn and appreciate that how one should present the results as part of visualization, right? All right, enjoy the video.
Take a country.
All right, hope you liked it. And this is something which is very close to me. And this is the way one should really present the work, right? And I'm not talking about that we should really get into the tech which Professor Hans Rosling used, but we really get towards that, and we can assist each other using that. And there are different tools and techniques and inferences so that your work really gets acknowledged appropriately, and also that should really reflect what you want to say. Okay, so yeah, I have 10 minutes, and now I'm going to the third part of the presentation, which is going to be very useful for the research community, for the upcoming budding scientists, already faculties in their institutions of higher learnings across the world, and also the visionaries, what I call CXOs, CEOs, CDOs, the visionaries in the management sectors as well. So this part is the future research and technology opportunities. These are my recommendations. All right, so here we are going to touch upon these 4 points every slide. That chasing unicorns is not worth it, knowledge triangle, Bayesian statistics, causal analysis, quantum computing, and digital twin. Let's start. So here, in the right part of in this slide, you can see there is a 2x2 matrix, which is split into 4 quadrants. And here we have, so what we need to really enable and what we need to drive as type of an action, and what is the kind of skill we need to have to enter into the domain where we would really want to focus on. You can go through that later on when we share the slides. But the key thing which I want to highlight is on the left part of the slide. That is, this is from a very interesting conversation, and then the excerpts which was recorded in the CIO magazine from Intel, Bob Rogers. What he says that generally people try to expect a particular individual who shall be able to behave like an analytics translator. Also, that person should know the wrangling and manipulating, working, analyzing, and visualizing data as a data scientist, as a data engineer, even also as data visualization expert. Remember, one individual, right? So that's what is actually people are trying to look for unicorns in the research labs, in the industrial setups, but unfortunately, unicorns doesn't exist. Even if they exist at some time. If you see the top right corner, these are the unicorns, what I mean. So it's not worth chasing them. So what we should do, rather, the best strategy should be that we should build data science teams, data science research teams in your research lab or in your industrial research setups with complementary talents. That's why you see, people these days are coming from different domains, and they are coming not only from the engineering domain, typically they are coming from sciences domain, from biology, from genomics, from sociology. And that's how the diversity comes in, and we can crack with innovative solutions, right? And remember, definitely, not to compensate for any skill sets, right? Let me go into that. Then this particular part of the presentation is emphasizing on the respect on the domain. As I was used to interview a lot of people who are coming for AI scientist, data scientist, engineer, or likewise, right? People try to drift, especially the students these days in the UG, PG, or PhD alike. They try to drift that, so if AI, I'm going to get a job, then, or in a machine learning or as a machine engineer, then why I should focus more towards the domain? I should focus and do some kind of online or offline courses in the AI related fields. But let me tell you, whenever I used to interview or I used to guide and coach people in the teams, then I found they might be very good into, tweaking the codes, or that was a joke that, people try to really, really getting, $100,000 just for knowing that what code to copy from the Stack Overflow, rather than hiring one person, giving $1 to copy the code from Stack Overflow or like. So the key thing is in the domain. If you really know your domain well, when I say well, I'm emphasizing double underline bold, well, then you can transform and translate your business problems, right, from your internal stakeholders, external stakeholders, into actionable technical modules which you can really build up as a product, and you can ship it, you can deliver it as a result to your to your management, to your stakeholders. So first thing is that you should focus on your domain, right? So as I'm an aerospace scientist by training, so that's why I am just giving an example that domain can be aerospace engineering. Then if you complement that with the very strong skill set of applied mathematics, right? You can be good in pure mathematics also, but I'm here emphasizing in the applied mathematics. Then you actually can go individually into as an algorithmic or research scientist as your career move, right? If you combine your domain specialism and your applied mathematics, then you can get into something what I call that you can start your career and accelerate your career into what is something known as engineering and technology teams, right? But the third leg of this triangle is from the software engineering and scientific computing. Most of us are already very much well versed and use scientific or technical computing tools such as MATLAB, Mathematica, or alike. But if individually people are good in that, they can become, in their career as a Python programmer, if they go into the Python as a learning tool, or a big data engineer or app developer or user interface or user experience developer or cloud or GPU compute practice. But if you complement these kind of, any of these, I mean, I don't mean that you need to master all of them, but if you complement, the technical and scientific computing and software engineering skills, along with applied mathematics, then you can get into data engineer, AI, or data scientist roles very easily. However, if you combine software engineering skills with your domain specialism, then you can get into business analyst or a scrum master. This is a term which is coming because of something, software management technology, which is known as agile methodology. But if you combine all these three, vertices of the triangle and master them, then you are actually going towards data scientist or data influencer domain. What I mean as a data influencer is in this box. And this is what I call as a path to the CXO level, right? So, and remember, this is a step-by-step journey. Don't try to take all these things in one shot and don't feel any kind of complex is not superior complex, not an inferior complex. But if you really master this knowledge triangle, then definitely you are on the path towards chief technology officer or chief information officer or chief digital officer or alike. However, which is based on the intelligence quotient, what I call IQ, right? If you have a Bayesian type of thinking, we'll come to that very soon. Then, which is also IQ-based knowledge which you can acquire, then you are on the path towards CFO, right? However, if you get into the behavioral sciences or economics, then which is driven by emotional quotient, EQ, definitely complemented with IQ, then you are going towards chief staff officer and that type of roles. This is just an indicator, but what I want to emphasize before I leave this particular slide is that don't miss on your domain specialism. This is your key tool and strengthening thing. However, on the top of it, hone your skills, build your competencies by these skill sets, right? Which are in the other two bubbles. Then you are really going towards from engineer to scientist, then to the CXO level and the like. Yeah, you can start your own company tomorrow. All right. So the second most important thing in the recommendation is on the Bayesian statistics and probabilistic modeling. As most of us as engineers, if one very interesting example which I used to quote most of the times in my offline interaction is that if I give you a particular cylindrical object, right, and let's say it has a diameter of 5 millimeter, then if I give you a vernier caliper and I ask you, please note that reading, and remember you are a NASA scientist, right? You're working with them. So there, or a ISRO scientist, I mean, respect to both of us. So the whole idea is that what should be the measurement? If an engineer says, or a person who is measuring says that diameter phi is equal to 5 mm, I would say respectfully that is wrong. As an engineer, we should say that what are my least upper and lower bound counts, right? So what is my the right answer should be the 5 millimeter plus minus point, say 0.2, right? So that is the probabilistic nature inherently is available in our nature, right? So that, and there is a beautiful way which Thomas Bayes has, kind of made a whole framework around that. That is known as Bayesian probability. So we should really get into that part as part of our research. And there's a wonderful work published by Murphy that is on machine learning, a probabilistic perspective. And one of the heroes of the Bayesian statistics is Professor Andrew Gell-Mann, and he has written his book on Bayesian data analysis that you can also refer, and which is based on the graphical as well as on the mathematical modeling. The third part of my recommendation is on the correlation. As you can see this in the cartoon as well. Don't focus on the correlation, please, right? And this happens sometimes humorously in XCD as well as you can find these type of cartoons. And actually, ironically, this happens at times in the conversations. So if you really are not very much well versed with the three vertices of the triangle, you can only sometimes get into this kind of confusion or dilemma. That if there is a sales are going up and then people say that we found this correlation, everyone should take a razor. That's not true. So don't let correlation steamroll causation. So what we should do then, we should focus on the causal analysis, causal inferential analysis, and how you can do that. There is a person, Professor Julia Pearl, he started this field in artificial intelligence on the causation and causality theory. And he has his recent book in 2016, the book of Why. Please refer to that, and that's where we should really start investing our time and energy. The third one is on the quantum computing, and this is again one of my favorite areas. I have one talk which I delivered. It's available in my LinkedIn. You can refer to that. So these are different complexity classes, what we call as P hard problems, NP hard problems, and these days we have the tractable problems is BQP, and there are certain intractable problems that is NP hard problems. And there are two key algorithms, and there are many more which are coming along by Professor Peter Shor from MIT, Shor's algorithm, and also a couple of other algorithms around that. So let me tell you, I mean, today we are all focusing towards towards supercomputers earlier, last decade or so. Now the supremacy is going towards that who is going to build the first quantum computer. When I mean building first quantum computer, what I mean is a tolerance, error tolerant quantum computer to the maximum precision. There are already quantum computers available, which are commercially available also. People are trying to use, right? So focus on, again, on the knowledge triangle, that if you are good in your domain, then only quantum computing makes sense. Otherwise, it's a quantum mechanics, physics area. To give a quick highlighter on that, what could be the potential applications of quantum computing in aerospace domain. So I have listed a couple of applications which are already going on, and interested people can visit the Airbus Quantum Computing Challenge, which was live in 2019, second part of 2019. And NASA Ames facility is having a quantum computer developed by D-Wave, Canadian company. So they are using it for these kind of applications in the AI, and they have a lab in Ames that is what they call as QUAI, quantum AI. And we can use this in aerospace for full domain mapping and full domain optimization rather than suboptimal solutions. That is the power we can use. There are many other applications, but this is not the topic of today. And there is a field which is coming along, which is known as quantum machine learning, where we combine our knowledge, domain knowledge of machine learning with quantum computing. See, again, I'm emphasizing on your domain. If you know machine learning well, then you can put into a bigger envelope of quantum computing, and then the overlap happens very well. Yeah. All right. The last recommendation which I have, which one should really explore, potential of getting into very high quality research and also in the industrial TRL4+, is on the digital twin and intelligent machines. Digital twins offer a virtual representation of the actual physical unit, right? So we can use that, and there are already wonderful applications and demonstrations which are there available in the public domain. Rolls-Royce also have a digital twins in the power system customer 4.0 strategy, which is available online. You can look at that. But these are the other mechanical and aerospace sciences companies which are mastering the digital twin and aggressively working towards that. All right, with this, I end my presentation. Right, so the whole mantra which I would like to leave all of you with is that as an engineer, as a scientist, our mission and our objective should be, that's what I live with, is make complex easy. Yeah. Thanks a lot. These are my details. I look forward to contact and conversate and collaborate with you. Thank you. Over to you, Ajay.
Thank you very much, Rajnish. That was a very interesting talk. You kind of gave an overview of a lot of different things and very interesting things that are there.
Thank you.
There's some very interesting questions. Maybe I hope we have some time for questions.
Sure.
So let's, I think anybody can mute themselves to ask a question if you have. Maybe we can start with some of them that are there already on the chat window, I think.
I'm also looking at the chat window.
For example, like how is the digital twin different from CAE simulations?
Okay. So if you see, one of the key facets in the digital twin is that it's a closed loop system. So simulations, what we do is that there is an input and we analyze, and then we really produce certain actionable and informative results for prescriptive or predictive analytics for our domain to the stakeholders. Sorry. Can you mute, please, if you're not asking questions?
Yeah.
Thank you.
Please go ahead.
But in a digital twin, whatever simulations what we do, there is a closed loop. The first part comes as a hardware, right? We get the real time, near real time, if not possible in the real time, the data which is feeding into our simulations. We then simulate and also trying to make our models and trying to, sometimes, most of the times, especially in the digital twin, we focus on the ROMs, the reduced order models, right? So then these ROMs feed the information into our digital twin, actual physical hard prototype. So that if there is any kind of problem, so we can come to know about that using if we are far away, using IoT. Otherwise, we can use our own technology, right? If the product is in front of us and it's accessible to us. Then, so the key idea is that the simulations are complemented with ROMs and also with the near real-time information which you are getting from the hardware. Point number two. Point number three is that when we made the models or the ROMs, the output of that goes as a closed loop into the actual hardware to work and to get the actual actions using the sensors and actuators. Yeah. Thank you. Does this help you, Hari?
I think there's also an interesting question coming from Sitikanta. Maybe we can, in the meantime, maybe Hari can think about it. So how mechanics-based research can advance mixed reality research? or can you please tell me about specific applications? Can we simulate deformation and damage in immersive space?
Mm-hmm.
And also, I think he follows up with saying that is there any commercially available platform for this?
Right, right. This is a wonderful question. Thanks, Professor Shrikanta. So, what happens in the as far as platform is concerned? Definitely, there's a whole domain known as CX, customer experience, and UX complemented with AI. And there are tools in the UX domain which deals with the mixed reality uh, simulations known as by Unity software, and the hardware and the appropriate immersive technology tweaking of the software is available by Hololens as a hardware from Microsoft. So that is available as far as technology is concerned to get into and get our hands on the immersive technology. Addressing to the second part of the question, which is on how we can simulate deformative deformation in immersive space. Yes. So what happens is in the immersive space, there has been certain applications where one I got an opportunity to do that. So what we did, so when we wear the headset, we really get an opportunity to get into the full scale analog model of the helicopter engine, right? And you experience that rather than getting outside view, you are inside, and whatever the tweaking which we need to do, we can see that. And because of the physical boundaries, if there is a problem in the Singapore or let's say in the Australia or somewhere else, then I can, using our telecommunications, I can tell that person where I'm looking at actually, where is the problem? And then tell that person that, what you should really do. So in that way, the deformation or the nucleation of the cracks or the actual cracks, if we can see that using these kind of technologies, which we can communicate further back. And from the VR perspective, the virtual reality perspective, people are started already using that in simulations. I mean, Rolls-Royce is one of them. We have a VR center in Dahlewitz in Germany. And as I said earlier, so Airbus is at a quite advanced stage. Please follow that, the A-Cube initiative from that. The third part of the question was on the research advanced in mixed reality research. Yes, that's a wonderful perspective. So what happens, Professor Roy, that whatever we do, so it is there in the 2D animation into our systems, right? At the max, we can have some kind of a 3D animations around that. But now imagine that whatever, let's say using a DIC or that type of techniques, we have some kind of a simulation of a composite crack or equivalent cracks. We can map that into mixed reality, and we can see that the level of learning which we can produce as a product, as a research product, as a technology product. And also the second part is that as a part of a learning for students is exclusively different. That really pushes the boundary for the mixed reality research in the domain when we are designing, when we are analyzing, and when we are going towards digital twin equivalence as well. I hope that helps. If there are any further questions on it, I mean, I'll be more than happy to take it with you offline. Yeah.
I mean, I had just a follow-up to that. Since you talked about HoloLens, I mean, HoloLens is extremely expensive, right? I mean, I think it's probably not, I think it's cost like $3,000 or something, if I'm right. At least that's what it was last I looked. And I think they came up with a new HoloLens 2 as well recently, I guess. Right. Is there a cheaper alternative to this when you're looking at mixed reality? I mean, of course, there's a lot of them in augmented and virtual reality. But for mixed, is there anything alternative for HoloLens?
There is one very, I mean, actually it is known as a stealth company. Its name is Magic Leap. It is not, but the technology they are developing, I believe it is in the US. So they are working on it very aggressively, and their products sometimes come out, but the technology, I mean, the rest, all the information is hidden. That's why it's a stealth type of environment. But there are equivalent such as from HTC, I remember once I used Oculus. I think it's a product from HTC, if I recall correctly. But they are more towards the VR. But the MR exclusive, what I'm aware of, is from the Microsoft as of now. But these technologies sometimes are expensive, you're right. But to offhand, I remember is from the technology companies, the Magic Leap, which one can follow for the products, software and hardware. And the second one is from the HTC, and one, if I recall correctly, the Oculus. I have reports, I mean, I can send that if you're interested.
Okay.
Yep.
That would be nice. And there's a couple of other questions just to kind of, so one of this was like, can we use machine learning and deep learning to enhance scarce material property data sets with limited experimental data? I think this is a very interesting thing.
May I know who asked this? This is a wonderful question.
Shashi.
Shashi,
I think
thanks,
this was
Shashi.
from Shashi. Yeah.
Thank you. So this is the question which is there, which especially the reliability engineers are grappling with decades. So, and especially when I say from the aerospace, sector. Why reliability engineers? From the sparse data set or the scarcity of the data set, what we call as sparse data sets. So what happens is that if we really want to do the actual holy grail, that is the testing, and we want to get the data, we want to really explode the engine, and we do explode the engine, and we do explode the airframes, full scale, one-to-one, actual, right? That costs huge money. But the data what we get is limited, right? And the kind of instances are uncertain in the nature, right? That is different type of errors which we have to, uncertainties we have to deal with, epistemic or aleatoric. So the question is that how to deal with the sparse information, which happens in the real time, and we still want to solve or troubleshoot it quickly. So what we should do is, in machine learning, there is a technique, and there's a good amount of research also going on, and published literature is known as augmentation. You can augment your data. For example, for machine vision, there were 600 or 1800 images, 300 images for the 6 classes which I showed for the MDT technique, right? So there are 1800 images, but if you really want to train on neural networks, convolutional neural networks, or different architectures around that, that is really sparse, because these algorithms are sometimes data hungry. What we should do is, what we can do is, we should go and complement that with data augmentation. Data augmentation is that you take your original data set, and you can do rotations. You can put different type of obstructions around it. You can augment your original data to develop different data types and data sets, which we can use it further for your data hungry algorithms. That's point number one. Point number two is, there is in the machine intelligence or artificial intelligence related research, there is a wonderful technology or algorithm that is GAN. So adversarial networks, generative adversarial networks. That also we can use to augment our data and then feed our data hungry algorithms. These are the two which are quite useful.
I think that's pretty interesting to know. Just to add another thing in there. Okay, I think there's a follow-up question to that by Jay. For sparse data sets, especially the images, can't we use transfer learning without much of a loss in accuracy?
Yeah, sure, Jay. I mean, yes, we can use transfer learning, but sometimes the type of data sets that we have, especially when we are, as I said, the reliability engineers, they really want to look for the statistics perspective, and especially the quality and the certification authorities, they want to see not only the accuracy, and this is the kind of very interesting discussions which keeps happening with the people around that, where I work with the projects in the consultancy, that do we really focus on the accuracy? We need to focus on the precision or the recall, right? The confusion matrix in the machine learning community. So we need to focus on that how much actual data we can create with the original images. Definitely transfer learning is one of the technology where we can use the already existing heavy architecture and use the last fully connected layer around that. But the focus, I would emphasize that from certification perspective, which is very critical, especially in aerospace and equivalent domains, is that we should use the original data set, focus not only on the accuracy, but also on the recall, right? So how many true positives or false positive we are getting, that number we need to really focus on to begin with, at least. Yeah.
Nice. There's a couple of other things. One, again, like goes back to the idea of mixed reality. Where is mixed reality expected to be a part of all the production lines in the near future, or dedicated to high value NDT and defect management? I think this goes in line with a lot of things that you were showing in there of how machine learning can be applied in these production lines and they can be used to reduce defects and things, I think. So the question goes in that direction. So it would be nice to know what you think about it.
So, certainly. I mean, if you see, if you go like 20 years, back from today in the timeline, then we see that VR, virtual reality, was itself like, oh my God, I mean, what are you talking about, right? So similarly on the augmentation using Google Glass or smart glasses, a different type of lens from Sony has a patent on that. So that technology is really moving ahead, and we are accepting it as it is, and that's become our status quo today. So from that perspective, if you see, I sincerely believe that VR has already actually entered into the trainings for the newcomers, lateral entries, or the like the graduate students. So for complex machines like aeroplanes or jet engines, which are expensive hardware, and sometimes we can not mobilize those trainings of people. And now, in fact, there is, because of Corona, there is even more need for that. So virtual reality is already taking that place, right? So from mixed reality perspective, it has started coming. I got an opportunity to use mixed reality for different understandings on the flow and the injection pipes. So, which is a very complex architecture. There are a huge amount of lines. It's like you have to tell somebody that how you're using what are the veins and different arteries going on in your human body. And by the way, I mean, from a different perspective in the different domain, in AI in healthcare is also getting a lot of attention from VR, AR, and now moving forward on the MR technology. That you can immerse into that field and then start using with the cut section of a human body, and then start using it rather than actually using the dissections of the physical body. Yes, I mean, to answer your question, yes, it is coming. The way is coming. But let's not miss the bus. Thanks, Christian.
I think Shri has another question which kind of goes in this direction. Do you find the application of digital twin and in automotive industry or automotive domain?
Oh yes, there are wonderful papers. One I have written, which is a white paper, but there are research paper available. I can share the links if you connect with me in LinkedIn. But one talk which I organized long back with an interaction with the VP of Engineering from Bosch. So they have invested 5 years in development of an actual digital twin of a particular small sensor. And that information is, I believe, available on the website as well. So that particular type of applications in real time are already available, point number one. From mechanical sciences industry, ANSYS is leading the front along with Siemens, right? They have their digital twin summits, a lot of research work available for automotive industry, and ANSYS have a wonderful case study on a hydraulic pump, and along with the CFD, and how digital will help that to solve and troubleshoot the problem in near real time. As I said, that's a closed loop, not an open loop like simulations. Yes, there are huge, huge applications. From aerospace domain, industrial gas turbines, which we use, there immediately we can use from mechanical. From aerospace domain perspective, people started using and developing its component level digital twin. As I said, I mean, to develop a digital twin of a sensor in Bosch, it took 5 years. These are research projects. That's why I put that in third section of the slides of the presentation. These are research related problems for industry as well as for the academic research. So it takes time. So let's not look for unicorns, right? And these are not easy, quickly doable problems, but these are the problems which we focus. They are state of the art, high impact, high value, high ROI research on investment as well as on return on investment problems, right? So these are the quick key applications which I am aware of. And
Well, very interesting. I think, I mean, I think if I look at what you said and overall, just to summarize your lecture, I think it's pretty much it's something that's going to happen and it's already happening. And either we are we are getting on board or we are just not getting on board. I think it's
right.
just a matter of fact that people will start using it and we just need to get used to it, I guess.
Indeed, indeed. And I mean, in the end, I just again want to strongly emphasize for all the people who are there right now that, especially for the faculties as well as the practitioners or the CXOs, that please focus on that we have to emphasize on our domain knowledge. That's the competency which you are carrying. That's a skill set, because complemented with your different behavior and functional skill sets, that becomes a competency. When you complement that with machine intelligence or equivalent information, then that really helps you to go forward in your research or your career, right? Different paths you can take up. But never underestimate your domain knowledge. So please focus on your curriculums very well, master that, complement that with more knowledge, then you are the winner, right? So I look forward for any kind of questions. If you have, you can connect with me on LinkedIn, so we can have any kind of discussions for any projects. Yeah, there is one person has raised the hand. Sorry, I missed that. Is there any question? Please unmute if you like to ask.
Yeah, I think you can unmute yourself. Dr. Faizan, please go ahead. Hello.
Yeah.
Hi, please go ahead. We're not able to hear you.
Okay, I think we lost him.
Okay.
There are a couple of other questions. Okay, I got the question. How soon Met guys should pick AI before they are made irrelevant in industry? Okay, so it's one of the most common questions which is available in the debates and discussions. But as I said, and I am the strong ambassador of that, mechanical aerospace industry and the people who follow that school and the doctrine, they are never going to be irrelevant. They are going to be even more relevant, if I have to say so. That's why I gave the whole concept of knowledge triangle. So you should learn along with your curriculum. Right? So there is nothing like a perfect timing that when you should learn, but the key facets of artificial intelligence, machine learning, or deep learning is that these are smart ways of optimization, very smart ways. So what you should do, what you should focus on, you should focus on three things. You should focus on scientific computing. Take any particular scientific computing language. If you have never done any programming, then I would say Python. Otherwise, MATLAB is wonderful. The second thing you should focus on is mathematics, applied mathematics, and precisely on the linear algebra, multivariable calculus, and probability and statistics, right? So if you do that, And then, as I said, and I again emphasize, if you're good in your domain, then you are the package which nobody can, you know, resist. You are on the successful path. You are the winner. So just do that, and that's it. Yeah. Hope that helps, Faizan. Okay. There's one
more.
Prakhar Goyal. Yeah, please ask question.
Yeah, good morning, sir. My name is Prakar Goel, sir. Am I audible?
Good morning. Yeah, please go ahead.
So, sir, I have been learning this machine learning and data science from the past 7 months. And I have been doing projects with respect to regression and classification, and I'm in the mechanical domain. I'm doing masters in mid learning. So
Okay.
I was working on this project of LSTM, RUL, where we'll predict the life of the engine using the sensors of the engine. So I have been given the data set. So I want to proceed with that project in the next semester. So can you please guide me through it? So how should I begin with it, and what are the key aspects that I need to take in mind?
I think that's a more one-to-one question. So if you can connect with me, my credentials are over here on the screen, then definitely for the people who are there, there is something known as Prognostics Center of Excellence by Ames Center, NASA. And the data sets are open source data sets available to all of you, for all of us to really propel the science behind it. So you can look into that, the Prognostics Center of Excellence data sets, and it has jet engine data set, it has bearings data set, it has smart batteries data set. So we can test different algorithms, as Prakhar was mentioning about the LSTM, that is long short term memory, and different other algorithms, and a lot of papers were available. It is like equivalent of Kaggle, which is a kind of open source platform for learning and competition for different people. So Prakhar, I mean, this is I believe, I think it's more of a one-to-one question. So if you can connect with me, I'll be more than happy to assist you. Yeah.
Okay, sir. So thank you, sir.
Yeah.
Okay, I'll do that.
Sure.
So, I mean, I think we have taken a lot of your time, Rajnish. Probably, if there's like, maybe we can take one or two critical questions. And there's one question coming in. Before that, I would probably put in my final point in there, final question to you, so that we can address it before we close it. So let's say for students who are there in the in either finishing their masters or bachelors or things, right? So most of the curriculum today does not have anything related to machine learning or AI. And most often, one of the things that I see on LinkedIn, especially, that everybody is doing is they go and do some of these courses on Coursera, Udemy, and all these things, right? I mean, of course, I'm not critiquing that, but it's a good way to learn. At least they're taking the initiative to learn there, which is very nice. But what are the things that they probably, let's say, should focus on? I mean, apart from the domain knowledge is one thing for sure, which by the time you come to your bachelor or master, you probably either got it or you didn't get it, so you can't go do it back again, right? So we have to push that thing there. But that apart, with regard to AI or ML, like, I think, what are the things that people can focus on? Let's say one thing I would guess, like from what you said, is programming is probably a must. I hear a lot of mechanical engineering and civil engineering students who pretty much say that, hey, I don't have to, they're on two sides. One, they either do a lot of these courses and they just talk about this and forget their domain. Or on the completely on the other side, where they're saying, hey, I'm a civil or mechanical engineer, I don't do programming, right? So kind of what are your thoughts for somebody like that?
If you can see my screen, I have an answer for the people who are not very well conversant with programming and who don't want to do programming. Can you see my screen?
Yeah, maybe if you can enlarge it would be probably.
Yeah, I'll do that. Yeah. Okay. So, is it visible now? Okay.
Yeah.
I have hidden this slide. I mean, I thought if question comes. Okay, now question came. So this is something what is known as magic quadrant, as Gartner, again, business consultancy organizations calls it. And this I have taken it, this is the latest 2020 data, yeah. So for the people who are not very well conversant or don't want to invest their time in learning new programming language for that matter, right? So there is a new research domain which is maturing and which have matured to a level where people have started accepting the research publications, and the work or output of that also started becoming products. So that is known as AutoML, auto machine learning, right? Google has its own platform for that. And here I list a couple of leaders in that domain. And to begin with, which I have a hands-on, was H2O, which is in the, that's why it is in the visionary quadrant, the right second quadrant. So over here, you see, if you can work with H2O, there you just need to get your kind of pre-processed Excel sheet or SQL database, whatever. So you feed in that as an input, and then you can choose the software lets you choose particular algorithms, and then the rest of the things it do automatically. It has its pros and cons. That is always under research or also under discussion, like overfitting and likewise. But I mean, to begin with, if somebody would really want to test it and want to get the hands-on exposure, so I would recommend you go with the H2O.ai. That's the website as well. And NIME is the second one, and Databricks is also the third one. But to begin with, the people who are good, who don't want to work with programming, can start with the AutoML type tools, like H2O.ai, NIME, and etc. And to come to the question which you were asking about, that what people should really learn if they want to enter into the domain. I would suggest there is two very interesting literatures. If somebody really wants to kickstart and is interested in the history, then I would recommend the book by Peter Norvig. He is the chief scientist in Cambridge Machine Learning unit in Microsoft. So that is what one can follow to understand that when it started, right? And then what happened. So all that journey is there by Peter Norvig. The second one, when somebody wants to get into the deep of such as deep learning, then there's a recent book on deep learning by the people who also wrote certain key libraries on deep learning. So the book name is also Deep Learning. So I can share that later on to the people who are interested, or to everybody. That's the second one. And as I said, like the mathematics is the foundation of this particular domain. So from Stanford professors, so they have written a book. I forgot the full name, but the book name is Statistical Learning, Introduction to Statistical Learning, right? And they have two books. One is Introduction to Statistical Learning, and one is on a little bit more detailed mathematics around statistical learning. But they are in the R language, right? So R is a language for statistics, generally acknowledged by people in the statistics and applied mathematics domain. So, but the concepts are very well jotted down, little complex to begin with, but digested. Read it like novel, if I have to say so, and then reread it. This is the third one. And the fourth one, from the Python perspective, which is also one of the other proclaimed as well as wonderful language, which everybody is recognizing in industry, which I call as Maggie is recognizing. I like this word. I coined this word. Maggie is Microsoft, Amazon, Google, IBM, and Intel, right? So they recognize Python. If you don't know, you can start with H2O, as I said, to begin with. If you want to learn, then you can start with certain courses, or there is one very good book on learning libraries such as Scikit or Python by Giron, Eulerian Giron. He was in Google in 2013. So it's, I forgot the name of that book. But I can tell all the names of the literature. So this is, I think, if you start foundation with mathematics, complementing with the computing, scientific computing, then it's a good combination. If you are not comfortable or don't want to invest time in computing, okay, then you go for maths, domain, and auto ML. There are pros and cons, but it's okay. You can start with that. Yeah.
Thanks, Rajnish. I think that was that I think is quite helpful to the student participants here. Maybe when I would like to construct a supplementary materials at the end of the lecture.
Sure.
Maybe we can like get in touch again, and I think the
problem.
best thing would be to kind of list all these literature in there. So when we put it up, so people can actually access it if somebody did not get the name of it at the moment. Maybe we can take one last question from Vinay Padmajan. With such complex analysis, especially hierarchical analysis of airframe simulations, how do we differentiate causation from correlation? I'm curious since you mentioned data augmentation when there is a sparse experimental data available.
Okay, good. That's a nice question. Thank you, Vinay. So what happens is, causal analysis, as I said in the second recommendation of mine, so it is inherently built not only on the probability, what we call as a deterministic type of probabilistic analysis. It is based more on Bayesian probability or conditional probabilities, right? So given the particular conditions, we are going to have a posterior as well as the prior information from the data set. And then we are going to predict with a very sound mathematical framework around that. That framework is going to ensure that we are going as close as possible to address the cause rather than only merely showing the numbers as part of collinearity or correlations, as just one particular command in programming language. So causation, as I said, I mean, in industry, in one of the workshops, I remember, I mean, there's one very interesting concept. If you really want to understand that what is the root cause, which is the key component in root cause analysis, ask 5 whys, in chronological order. Why is it happening? Whatever answer comes, why that answer is there. Whatever that comes, then why that answer. So that is the qualification type of root cause analysis. If you really want to do the root cause analysis in the mathematical framework, that's the conditional probability and Bayesian statistics foundation-based analysis. So when we do that using the information which we do, we can do the machine learning, the Bayesian machine learning, or the probabilistic machine learning. From AI perspective, you can use, there is a framework known as TFP, TensorFlow probability. Rather than only using TensorFlow as it is for deterministic framework, you should use the probabilistic framework, which shall handle the, in the framework such as TensorFlow probability, and equivalent are also available, but that shall be able to handle all your data, whatever you are augmenting or creating using CAN or like this. Yeah. I hope that helps.
That's an interesting analogy to think about, I guess. I think we've already taken quite a lot of your time, and I think there are like still several questions. Some of these are very particular to probably like more of a personal case, like how do I do something? And I think you like you said, probably they can directly contact you on LinkedIn or connect with you on LinkedIn. I think that would be the best way to probably answer it. Maybe it might not be of interest to everybody. And I think there's just some questions which we can, I can pass it on to you, and we can see how to address it in the supplementary materials. Is there anything that you think could add in? And I would like to, yeah, go ahead. Sorry, Rajnish.
One last thing. I mean, thank you for everybody who have asked the questions and being there still. There are 35 participants. But if I'm not able to answer a few of the questions, pardon me. But I mean, I'll try to answer those questions as Ajay is going to send me. If you can send me your email IDs on LinkedIn, or we can connect through that, then that will be the ideal one. Otherwise, as Ajay said, so we are going to send and create some supplementary material. But thanks a lot, and thank you, Ajay. I mean, and as I said, like it's a prestigious, mechanics lecture series, as it was preceded by already two great mentors of mine or scientists in the world community. And thank you for starting it all. So brilliant. Thank you. Thank you, everybody. Over to you, Ajay.
Thank you very much, Rajnish, for joining in, spending so much of time, I think, to answer everybody's questions and giving a very nice overview on the entire topic. I think this is like something that we can keep discussing, and there's always going to be a lot of questions, and I think there's no end to this. I think we're just getting started, I would say, right? I mean, so we can always look into a lot more things, and thank you for giving such a nice overview and ideas of connecting all, let's say, facets of the machine learning aspects, not just the algorithmic part of it, but then also to look at how it's applied in the industry. And I think that makes it a lot more motivating for a lot of people out there, I guess. And also thanks to all the participants who joined in today, and I think woke up early morning on a Saturday maybe and kind of joined in, right? I mean, that also takes a lot of motivation to come in and listen to the lecture. And I think also there are a lot of nice questions in there. I'm sorry that I could not bring up some of the questions, but I'm sure you would be able to connect with Rajnish on LinkedIn, and we would also try to answer these questions in the supplementary materials. Thank you, everybody, for joining. I just want to, before you all leave, I want to let you know that there's another lecture coming up in the next weekend on 15th August. And this would be like slightly different. It would be talking about modeling of flapping wings, aero vehicles. I think it's like a CFD, and it's not a structural mechanics, but more of a CFD type of a problems analysis that is going to be done, and looking at chaos theory and nonlinear dynamics from a CFD perspective, especially in these flapping wing air vehicles. I think that's a very interesting topic coming in. I hope you would also join in there and make it as interactive as today, right? So thank you very much to all the participants, and also to Rajnish, and have a nice weekend, and see you next week then.
Thank you. Bye. Bye.